Good morning, good afternoon, and welcome to a very special VMware webinar, Fast Track Deployment and Data Analytics with VMware Greenplum on vSphere and VMware Software Defined Data Center. I'd like to introduce our speakers, bring them in. Right here you'll see Chris and Ivan. Hey Chris, Ivan, thank you guys for joining us today. Excellent. Before we get started, we do have a few housekeeping items that we'd like to cover. We are having a lot of these slides go throughout today's, but if you have any questions, please submit them using the Ask Questions tab below the presentation screen, and we'll do our best to answer all of your questions live today. In addition, we know that you guys are here to hear from us, but we'd love to hear from you. So leave us feedback using the Rate This tab also below the presentation screen. Without further ado, let's hand this off to today's speakers.
All right. Thanks, AJ. So again, I'm Ivan Novick, and I'm going to lead you through the first part of this talk. And really, we want to show you, like the title says, is how we're going to fast track your deployment, your management, and your creation of business value with data and with data analytics. So just wait for these slides to pop back up here. All right. So let's get started. Let this sit up here for a minute. Right. So let's talk about what is the purpose of data. And the purpose of data, to set today's context, is to create intelligence. We want to create intelligence. That's why there is this word, it's called business intelligence, but obviously it's intelligence for whatever context you're in. And these intelligent systems are needed today more than ever. There's never been more data available for processing. It's coming in at faster speeds due to the smartphones, due to the sensors, due to them being pervasive around the world. There's just more data coming faster than ever before, and it's not expected to slow down. So with that as well, I think the end users, whether they be the consumer or executives in your enterprise, have higher expectations for what's possible and for what should be delivered as part of your business offering or your enterprise offering. And at the same time as those expectations are high, there's always competitive pressure from other companies who are trying to use the latest technology, or from other competing interests that may be coming at solving the same problems you're solving, but maybe trying to do it faster or more economically than you can do. And at the same time, we're in the backdrop of global economic uncertainty. There's economic pressures, there's cost pressures, there's anxiety about the economy, and the technology itself is not getting simpler. It's increasing in complexity, and that increased complexity makes it harder to focus on getting the actual intelligence, the actual outcomes that we need. And you need this intelligence in order to allocate your resources, to avoid investing in the wrong direction because you were caught blindsided, and really having at your fingertips what you need to operate intelligently, effectively, efficiently in your enterprise and whatever it is you do. Now, looking into the future and looking into tomorrow and saying, well, what do we need from a modern data system? What are the key attributes that we aspire to and that users and customers, enterprises are looking for to meet their need, right? Number one is simplicity, right? We talked about the complexity. That complexity is really harmful. And what we need to do is make it simple. And part of that simplicity is the infrastructure and the deployment, but it's also part of it is the access to the data, bringing all the data together into one place so that it can be accessed together, or it can be accessed holistically with the performance, with speed at scale, with economic efficiency that you can manage simply in a single platform, and that can combine different types of data, whether it be structured business data from an HR system, or whether it be sensor data from a manufacturing plant. We need to combine different types of data and produce outcome-driven designs and capabilities that can be used in to generate actionable results from this data. And at the same time, ensuring privacy and security, so that nothing is compromised. So who is this relevant to? What industries? It's really all industries, right? Whether you're in a marketing function and you're doing email marketing or marketing on the web, tremendous amount of data flowing that can influence your decisions. If you're in financial services, whether it be wealth management, risk management, it's all, I won't repeat, data driven. Everything is data driven, whether it be healthcare, hospitals, institutions, or research. If you're in the retail space and you have thousands of stores and millions of product IDs to track and transactions, manufacturing plants are increasingly complex. Running a call center, you can only imagine how can I make a call center more efficient if I use data effectively. If you're in a government agency working on, civil affairs, financial affairs, or even military affairs, or if you're really in any enterprise with a very serious mission, you want to get your data together, organized, cleaned, cataloged, and in a usable fashion with high speed so that you can act on it. So what we're providing at VMware and with VMware Greenplum is a unified platform that enables from business intelligence to artificial intelligence that can transform all of your data into actionable insights at any scale. So let's get into that a little bit. So as part of this unified platform, we have several main components. We have the Greenplum component, which is what we're going to focus on, which is the data warehouse and the big data platform that is your consolidator and your analyzer of the data. But then as well, you've got to consider how to move the data, how to send the data through messages and streams through the VMware RabbitMQ, how to query the data for applications through Postgres, VMware SQL, and how to make it accessible in real time to applications through VMware Gemfire. So these different technologies come together to build a unified platform that you can build on your own infrastructure, on a VMware infrastructure. And we're going to talk today about how this all works on the VMware infrastructure to build this unified platform to do all these outcomes that we talked about. Now, double clicking a little bit into the Greenplum part of this platform, right? It has to handle both your traditional business intelligence, your SQL-based queries, but as well to run the spectrum from big data, data science, vector-based large language models, geospatial, and streaming data, and interfacing with all these different libraries like Python. So this is really a high level, and we're going to double click into it. So starting with the ingestion, data is no longer coming in batches, although it could come in batches, but to a large degree, data is coming continually. So it starts with the ingestion. It starts with having a streaming ingestion that as data comes in whatever format's coming in, CSV, JSON, Avro, ORC, binary, that it can flow directly from the source through message queues like Apache Kafka or VMware RabbitMQ and be ingested into a centralized platform for storage and analysis. And that can be used for processing and can be organized from the streaming stage all the way to the storage stage and the analysis stage. So it starts with streaming ingestion. Then we talk about the storage. When data is coming in large volumes, think about sensor data or transactions at a retail store or shipments in a logistics company that's shipping packages. The first thing people normally do is divide the data based on date. And these dates, let's say daily, monthly, or annual partitions help us to do one level of organization. Now, obviously, there's another level of organization, which is the table itself. So you've got schemas, tables, and it's really a structured data system where you can categorize and organize the data and make it ready for fast access, as well as index the data across all these different metrics so that you can use it effectively, that it's organized cleanly and things are in the right place. That being said, then we need to talk about scalability. So how can we make this system scale once the load becomes high? There's a limit to how big any one computer or one virtual machine can be. So you can only scale your computer so big before it's not available to get a bigger one or your virtual machine. So we do this all by horizontal scaling. All of our technologies scale horizontally, which means you add more virtual machines to make more performance and more storage. And that's key to the scalability of the platform. This is a more technical view of it where you can see there's coordinator hosts that take input and process those input and send out jobs out to the worker nodes on the cluster. And those are used for processing the data. Now let's talk about some of the exciting and newer capability, in particular when it comes to AI-powered semantic search. So what has changed in recent times is search used to be largely driven by keywords. And you probably heard about it on Google or through SEO, that you put in the right search term and then it finds that data you're looking for. That's a keyword-based search where it's looking for the matching words. What we're doing now is in our data platform is semantic search, where we actually pass the raw data through large language models and through AI models to generate vector embeddings, which represent the underlying meaning of those text, images, and video, and allow us to search for them based on meaning, right? And that gives us this new powerful search. So, for example, if we had thousands or hundreds of thousands of documents in multiple languages combined with images and videos, we could search through one interface in English or in whatever your native language is and find the relevant meaning with the various filters. Now, the way this works is that the text or the data is transitioned into vectors, mathematical vectors, often up to 1,000 dimensions wide, and it's indexed in our platform and can be found in milliseconds by searching for the closest vectors in a vector space. And that's the key technique that makes AI-powered vector search work in most new platforms and in Greenplum as well. So this enables this use case of finding all different types of things you're looking for in petabytes of data in real time across text, image, video, and then also using the other techniques, things like geography and time. So you can really do these kinds of search. What else is new with AI and with large language models is text processing. So you have input text generating output text. And so with this, you're able to do text classification. Let's say take this long text and then categorize or classify it into one of certain labels. So you could be labeling your data in high, massive parallel processing, or you could be summarizing it, translating it, or generating other text from it based on prompts. So this is text generation at massive scale. And that's what we're doing that's new when it comes to text and image and video. But then a lot of your data will be structured data, things like transactions and raw data like numbers and bank account transactions or machine records or things that are structured data. And that's where we bring a suite of statistical machine learning algorithms, which are classical algorithms that are well known to also do supervised machine learning and unsupervised machine learning, and be able to use this type of algorithms to do predictive analytics, as well as the AI powered work on things that are more unstructured data like text. So you can see here, we did a simple prediction algorithm to predict the price of houses. And you could be running this in our platform, but you could be predicting machine failure, predicting fraud, it's really predictive analytics is what this enables. And to make that easier, something we're building is called GPML bot, and that will help users to get faster time to business value, because it's hard to know, which of these 50 algorithms are going to be most efficient with your data. So we have this software-based robot that can help to run experiments that will help you to find which algorithms are most predictive in your use case, so you can kind of hit the floor running. When you get a platform, you get data in it, you can start generating predictive analytics quickly, even if you have less experience in data science or have a smaller team, you can move fast. Now, you can also combine these predictive analytics with other types of analytics like geography. We can search and query things based on location in our platform. You can use graphical analysis where you can look at relationships between, for example, on a social network, every point in the graph is connected to other points, and you can determine things like what are the subgraphs, what are the communities within the graph, how dense is the graph, what's the shortest path, what are the most important vertices in the graph. So these types of graph analysis are there, um, as well as being able to enrich your data with just programming. You can in the platform, you can do Python, Java, Perl, and R to analyze and enrich the data and do other unique or custom processing that may not be covered by an off-the-shelf algorithm. So let's talk about a specific scenario. In this scenario, we're working with an e-commerce company, and this e-commerce company wants to send out emails to all of their customers, millions of customers, to recommend what product they should buy, right? And to do that, we need to look at what products they've bought before. We need to look at similar products. We need to look at similar customers, and we want to generate a personalized email message to engage that customer. So we're going to store in our database all of the product information, the product photos, the customer information, their order history, and then as well the reviews and the product descriptions and images. So all of that data in one place. So phase 0, we do the data preparation. We convert the text and the images into those vectors that we were talking about. We do that in our product. We can either call out to OpenAI or we can do it locally on our platform if it's a privacy concern. And there's numerous different embedding algorithms you can use that are either open source or proprietary. So the nice thing about doing this in Greenplum is naturally massively parallel. So that enables the generation of these vectors to be done 100 times faster because you've got this large system that can send out these conversion requests and get them back and process them in parallel. The next phase, part 1, is to find the products to recommend to each customer. So we can do that by looking at their order history, and then we can do a similarity search based on product description, looking for similar products, right? This uses our vector search capability that we talked about, the semantic search, but we can also look for images that are similar to the product that they bought. So kind of similar images and feed that into the algorithm. And the good thing about Greenplum is you don't need yet another technology, right? So not only does it have the database to store the data, but it also has the vectors to generate the AI embeddings and to index them and to query them all together. And at the same time to find your previous order history. So you're not bouncing off of multiple systems here to do this. It's all in one place is the key point. So stage 2 is you want to further improve the quality of this recommendation engine. So we did it based on similarity, but we may want to look at some structured data. We may want to look, for example, at the pricing, the review scores. We may want to run some other statistical machine learning algorithm. In this case, we did a k-nearest neighbor, right? So you're bringing together all these different tools together, minimizing data movement and producing a more accurate and interesting recommendation for each person. And then bang, we have the recommendation. We have one recommendation for each customer. There's 1 million people with one product. Now we want to use large language models and generate a personal promotional email to each customer. And we can do that because we have the information about what product we're recommending in our database. We have the description of that product. We have the previous other customers' reviews of that product, and we can generate a unique prompt for each recommendation, pass it into the AI, and ask the AI, hey, given all of this context, who is this person, what they've bought before, what's the product review, what reviews they've done, customize an email pitch to them to engage them to buy. So you're going to get out 1 million different emails that are literally targeted for each person to engage them. And then just as an example, you would see the output, like, for a person, I think Bob here, Bob had bought this book, How to Play Guitar, and based on the history and the pricing and all these things, we had recommended to him this particular guitar. And this particular guitar had had some previous reviews saying that someone similar like Bob had said, hey, this is awesome as a first guitar, just what you needed to get started learning. So that gives us an indication it's probably good for Bob. And we put that into we prompt all that information in, and out comes this email. Now, to actually send out all these emails, you're probably going to want to have some additional levels of checks and balances to guarantee that you're confident with what's being sent out. But it shows you the power of what can be done in terms of customization with data. So with that being said, I'm going to turn it over to Chris to talk about how can we implement all this from an infrastructure point of view to make it successful.
All right, thank you, Ivan. So hello, everyone. So this is a bit of a change of gear, but it's to just showcase, as Ivan mentioned, this business value you can get from the data, this business insight is incredibly valuable. And you can do a lot with Greenplum as a platform in order to get that value. But we would be remiss if we don't talk about, how do you actually do that? Because all these ideas about what you can run in the platform, that's great, but you actually have to run this thing, and it has to be something reliable, something that can handle large scale. And so with that, we want to talk a bit about what platform kind of really supplements this whole idea, so that you can easily get all of this business insight. And so there's lots of platforms that exist on like public clouds. Those are great platforms for doing these kind of things. But if you want to be successful on premise, then there's a particular platform we recommend for Greenplum that really fits very well. So for that, we actually would recommend vSphere. And both are VMware products, but Greenplum, being a data warehousing platform, for all of these analytics at a very large scale. It needs a good environment to run in that can help you be successful on premise, as much as you would be successful, say, comparing to in a public cloud. So the vSphere side of VMware, it offers just such a platform for that. So when we look at the two architectures, so Greenplum, it is in the end a software-based platform. It's a piece of software, and that software has to run somewhere. In order to run at scale, it has to have a lot of hardware resources, a lot of compute, a lot of memory, a lot of networking to run. And as you go up in scale with your data, that becomes a particularly hard thing to do. But on the vSphere side, it provides a platform so that you can take those resources, take that environment, and being able to, provide features on top of that help you manage it. So when we combine the two things together, it's easy to see, when we have an architecture of Greenplum on vSphere, that environment works very well into this idea of you have a lot of data, you want to get business insight out of it, and you want that to be, a platform that's easy to maintain, easy to run, so that you can have a focus on running these analytics and getting that business insight. So breaking it down into a couple of the main benefits of putting these things together. So one is that you're running on virtual machines. We've all been there in the times of running everything on bare metal servers and the difficulties of doing that. And so virtualizing, everything gives a lot of immediate benefits. And I'll talk more about the specific benefits, but the high level is giving you elasticity in terms of managing those virtual machines, essentially managing how much resources you want to give to the Greenplum platform so that you can, get the most out of those insights at the fastest pace possible. And the virtual machines make it easier for just deployment and management so that you can get started faster. Now, there's a particular feature on vSphere, which is highly beneficial in this situation. I think this is one of the features I love on vSphere, which is vMotion, because that really gives you the ability to make the environment easy to manage, to help with routine maintenance, avoiding downtime, dealing with expansions. It's a very critical feature in making the environment more accessible. And then on the availability side, this topic being a little more specific to Greenplum, if you know it, there's the ability in such an architecture with Greenplum on vSphere to run without mirrors. And so that actually just makes Greenplum as a platform a lot easier to manage and maintain, better performance. And then along with virtual machines is virtualized storage, which that really shows on the separation side of having a separation between your storage and your compute, lets you independently grow those. And the abstraction provided by vSphere gives you the ability to use whatever storage provider you prefer, whatever you're already using. So digging down into those two a little bit more, but not too low. So Greenplum on virtual machines at a very high level, Greenplum, like I mentioned, it's a software-based data warehousing solution, and it's running on virtual machines. We call those Greenplum segments. They have compute, they have memory, they have storage, and that's all running on top of a vSphere system, the hypervisor. You have the actual physical servers, which would be providing the actual physical cores and memory, and then the storage virtualization for whatever might be providing that storage. So going back to some of those topics I mentioned, vMotion, just showing as a quick example, the reason why it's so beneficial is that for a platform like this, you want it to be easy to maintain. You don't want to have to deal with downtime and all the complexities of that. And so something like vMotion really complements running a large scale data warehouse like Greenplum, because you get the ability to do, even at the basic level, of putting servers in a maintenance mode, and while online, without any impact to Greenplum itself, you can vMotion to the other physical servers that are available and continue running. And it's a simple idea, but I don't want to understate the importance of having a feature such as that. Now that same feature actually complements the other topics. So when we have virtualization, you want to have the ability to independently scale your compute. Because as you want to increase your workload for finding new business insight you can run, new algorithms you can run, or having more users that you're going to put on this particular platform, you want to be able to just increase the compute available for that. And so that same feature, going back to that vMotion, actually lets you be able to do that online in terms of adding more physical hosts, adding more compute, providing that into the Greenplum platform, and being able to expand your use cases. And then it goes the same way on the storage side, because of of course, data is always growing, and will very often outpace everything else that grows. And so that virtualization of storage for the same ability, you can independently increase that. And then the mirrorless Greenplum, just mentioning this one because it's an important topic for those that know Greenplum well as a platform. Removing the traditional mirrors that are run for these Greenplum segments that I mentioned, that makes the system a lot easier to maintain. It makes it a lot more efficient because then you're not worrying about maintaining those mirrors and writing to those mirrors. And so incidentally, this ability to run a mirrorless Greenplum is actually a result of making these choices of using something such as vSphere. That virtualization of your compute and storage gives you the ability to do an architecture like this. And so not only does it help just in maintaining Greenplum as a platform, but it provides functionality on top of that you otherwise can't get, such as being able to run a mirrorless architecture. So these ideas, there's many more features and benefits of running that. It's a very long list, but those are the things that kind of line up that if you want to be successful on premise with Greenplum as a platform, running all this business insight on your ever growing data, then these are good choices to run, and for that architecture and for those infrastructure that you would pick. So to give a particular example, here's an anonymized use case, and so this is a real platform that does exist, and this particular corporation, we'll call them ACIE. This ACIE corporation, they're very much realizing the benefits of running on a platform like this for all of their AI needs, on top of Greenplum. And so this corporation, say it's a manufacturing company. It has a large centralized data lake, data warehouse, and this is where they put all of their supply chain information, marketing information, finance, inventory, pretty much just everything goes in here. And so this is a very, very large data lake, a very large warehouse of hundreds of thousands of tables. And they use it throughout the organization. And so it can have, 5,000 analysts, a day running 30 million queries across these, multi petabytes of data. And so like this platform, like it's big, and those 5,000 some analysts, they want to be able to, get the insight out of the system without having any particular issues. And so this corporation actually recently has been making this switch from an older system into the thing that I just described, this architecture of Greenplum on vSphere, in order to get all of those benefits that I just mentioned. And so they have a large this large virtualized system for the Greenplum platform that is very successful in providing a nice stable platform that's high performant and can handle this massive scale that this corporation runs at. So getting to the end here, and so just wrapping up, and then we'll get to any questions that there might be. Getting started with all of this is actually very simple. That's one of our goals on this. And so choosing the right platform of vSphere for virtualization for Greenplum to put all of this together, it's very easy to actually take and download, what we call the virtual appliance, which is an all-in-one virtual machine image that gives you everything you need to take and deploy Greenplum and set everything up. And get that, get very quickly into the position where then analysts can, reach the platform, input data and run the queries and start getting the business insight. Okay.
Great.
Thank you, T. Let me bring us all in here. There we go. Cool. So I do want to just start off by saying thank you guys for joining us today, for today's live presentation, to Ivan and Chris for presenting today. I know that there's a question here about a free community version for VMware Greenplum. Would you guys be able to elaborate on that?
Yeah, there's so Greenplum technology is open source, and there's a Greenplum GitHub page. You can easily find it by searching Greenplum GitHub on Google. And there's the free open source builds that you can install, and you could give it a try. We also have a lot of YouTubes, but a couple of YouTubes that show like how to deploy the single node. You can give that a go, or you can try. I think we have a Docker build as well. You can try out. But yeah, you can give the open source version a try, but you can also just go and get the virtual appliance as well and run it on vSphere and give it a go that way. That's not a community version, but I think it does come with a free trial that you can kick the tires.
Excellent. I think the next question was, how does someone get started, or how can they find more information? I think you just did a great job of explaining that already, Ivan, but they can also see that here on the screen. And I think the link, I did not include it in the attachments section, but I'll get the link from Ivan and Chris and send it over in the post of an email so everyone has access to VMware Greenplum on vSphere and the VMware Docs site that you see here on screen.
Sounds good.
I think those are the two questions that we had. I do want to just shout out Ivan. I know Ivan is coming back on the webinar program, and he has a presentation, I think, in October, optimizing data architecture, a detailed review. I'm not sure if the date has been finalized, Ivan, but if you guys enjoyed seeing Ivan here today, you can see him again next month on the same webinar program. And then unfortunately, we don't have Chris on here next month, but we'll find some time for Chris to come back on as well.
Sounds good.
Excellent. Well, any closing remarks from you both, Ivan or Chris?
No, I mean, it's like we said in the beginning, it's never been a more opportune, exciting time to work with data. And the great thing about running data on a platform like vSphere is you really just have that full control of your own data, right? That it's in your possession, you own the data, um, and you can customize the system exactly the way it needs to be, but it's also super simple to automate and run everything. So I think we're going for simplicity, but also giving people full control of their data and their environment and fast time to business outcomes.
Excellent. Well, once again, thank you, Chris. Thank you, Ivan. And for those of you who have been continuously joining us for webinars, I'd like to introduce Marcella here. Marcella's joined our team and will be helping out with webinars as well. So again, special thank you to the team here you see on screen. Like we mentioned before, if you'd like to see Ivan again, he'll be presenting on optimizing data architecture with VMware Greenplum in October. And if you want more information from VMware Tanzu, we have Spring One Tour, which will be taking place October 17th. Is all virtual. You can view it at the comforts of your home. If you did not join us for Spring One at VMware Explore, this is another opportunity to get all the great content that we had at VMware Explore last month in August in Las Vegas, directly to your screens at home from the comforts of your couch in your offices. So again, thank you guys for joining us today. All the links that we have talked about throughout today's presentation will include in the post-event email. That's including the webinar registration page for Ivan's upcoming webinar and Spring One Tour link as well. All right.
All right.
Thanks all. Have a great
Thank
week.
you.
Talk to you guys
Thank you,
soon.
everyone.
Bye-bye.